Okay, so this is part A of the diode lab. So what we have is honestly a pretty simple setup. We have our power going in, then running through a diode, and then through a resistor into ground. Basically what's happening here is we wanted to change the amount of, we wanted to change the power, we wanted to vary the voltage to see like how the current through the diode behaved. And what happened was we've got this graph here, and basically what you see is that there's no current until you get to around 400 millivolts, which is just the threshold voltage of the diode, and then after that you see an exponential increase in current. So yeah, that's basically it for the IV characteristics. So this is part B of the diode lab. It's a half-wave rectifier. Right now the setup is fairly similar to the last one. All you have is your diode, power source, and resistor. But we ran an AC signal into like as a source instead of a DC one, and that creates a graph here, which is basically, it's called a half-wave rectifier because your input voltage versus your output voltage will never go negative, and that's because just the effect of a diode, when this goes negative, the diode doesn't allow for that negative current, so it just flattens out at zero. And then the next part of this lab was to put a capacitor in, which I'm actually going to do now. So the capacitor goes in series with the resistor. And now I'm going to auto set just to make it a little more clear. So obviously the input isn't changing, just the output. So what we see now is like this little wobbly line, and this is essentially like how you can convert an AC signal into a DC one, because here you have like a little bit, you do have a ripple effect, but for the most part this is a fairly straight line. Like before I did the auto set, that was very difficult to see any difference at all. It's also worth noting that the range right now is like 50 millivolts at a vision, so this here is actually pretty tiny compared to that peak. So, and it's also definitely worth noting that the maximum and minimum are different, which is just like kind of a natural effect of the diode, which is in part C kind of what we try to reverse. So yeah, I think that's everything for this part. Hi, this is part C of our half-wave rectifier lab. So what we have set up right now is an active half-wave rectifier that uses an op-amp, a resistor, and a diode. And basically what's happening is that you're basically splitting the wave in half, but it's keeping the amplitudes of the maximums of the wave the same. So if you look at the waveforms on the computer, you can see that the maximum values are the same, which is basically the purpose of having an op-amp to make an active filter. Because if you were to run it straight through the diode, like we do in A or B, you have a voltage drop through the diode. And then another interesting thing is when you increase the frequency. So just have a screenshot here. When you increase the frequency, you get a much higher slew rate, which just comes from like the qualities of an op-amp essentially. So I think that's everything for part C.